welcome to the debate. Today we are taking a sludge humor to one of the most protected pillars of modern science, the second law of thermodynamics. We're looking at a set of 2026 documents by Zachary David Enfield, specifically PhD versus Zach and the temporal threshold.
And, to be clear, when you say sledgehammer, we're not talking about some new discovery that disproves the math. We're talking about a linguistic argument. Enfield's claim is that the math of physics is correct, but the English language we use to teach it is, well, a lie.
A lie with massive consequences. The core question we're really debating is this. Are the heat death of the universe and the impossibility of time travel actual physical laws, or are they just linguistic traps, metaphysical prohibitions that we've mistaken for engineering limits?
It's a really provocative thesis. Essentially, he's arguing that by using words like waste, decay, and death in our textbooks, we've basically gaslit ourselves into believing the universe is dying, when in reality, it's just reconfiguring.
I'm the advocate, and I'll be arguing that the second law of thermodynamics is, as it's currently taught, a direct contradiction to the first law. I'll make the case that entropy isn't decay. It's just a shift in information, and that time reversal is a proven physical reality that we just haven't scaled up yet.
And I'm the dissenter. I'll be arguing for the practical utility of the standard model. I'm skeptical that microscopic reversibility, what we see in quantum systems, translates to the macroscopic world we live in. And I believe that before we just throw out 150 years of academic consensus, we need to acknowledge that usability is really the only metric that matters to biological life.
All right, let's begin with the position statements. I want to start with this concept of linguistic failure. This is really the foundation of Enfield's entire critique. So every physics student learns the first law, conservation of energy. Energy cannot be created or destroyed. It's eternal. It is a constant quantity.
Right, the box is closed. Nothing leaves.
Exactly. But then, typically in the very next lecture, they're taught the second law using a completely different vocabulary. They hear words like loss, waste, running down, and decay. Enfield points out a fatal contradiction here. If energy is conserved, it cannot be lost. If it's eternal, it cannot die. We are forcing students to hold two opposing concepts in their heads at the same time, that the universe is a closed system where nothing vanishes, but also that the universe is running out of fuel.
But this is where context is king.
Is it context, though, or is it a frozen assumption? Enfield argues that heat death, this idea that the universe ends in a cold, dark soup, it assumes that the universe will just stop evolving new constraints. It assumes the rules of the game are static, and this leads him to his most explosive claim. The arrow of time is not a law. It's a statistical tendency, and therefore, time travel is not impossible. It is merely not yet scaled.
I understand the logic, I do, but I think you're glossing over the difference between ontology and utility. I acknowledge Enfield is mathematically correct. Energy is not, ontologically destroyed. The atoms in a burnt log are still there. The heat that was released is still in the room.
Exactly.
However, usability is the only thing that matters for human existence. If I have a tank of gas and I burn it, yes, the energy is conserved somewhere in the universe, but I can't run my car on exhaust fumes. So to a living system, which requires a specific gradient to survive, the distinction between lost energy and reconfigured energy is purely semantic. If I can't use it, it might as well be gone.
But that semantic difference shapes how we approach engineering problems. If you think it's gone, you stop looking for it.
Perhaps. But I'm also skeptical about the leap Enfield makes from things like spin echoes, which are microscopic reversals of quantum states, to, human-scale time travel. Complexity isn't just a nuisance. It might be a law in itself. Just because you can reverse a single wave in a controlled metamaterial doesn't mean you can reverse a human brain without scrambling all that information. And I also want to defend the role of credentials here. They act as a heuristic for trust. We can't all rederive the laws of the universe every morning before breakfast.
And that brings us right to the core debate. So point one, the contradiction of entropy. Is it decay or is it reconfiguration? I want to look at this solar panel analogy Enfield uses because it just dismantles this idea of waste.
Okay, so walk me through it.
Imagine a solar panel lying face down in the dirt. The sun is beating down on its back. The panel produces 0 voltage. Now, a physicist looking at that system might say the sunlight is waste or useless heat. But is the energy actually useless?
In that configuration, yes, of course.
No. The energy is perfectly potent. The system observing it is misaligned. Enfield's point is that we call high entropy states waste only because we lack the technology or the alignment to couple with them. Entropy is a measure of our ignorance, not the energy's quality.
That's a clever philosophical trick, but it ignores the cost of alignment. To flip that solar panel over requires work. To take diffuse, high-entropy heat and concentrate it back into a useful form requires a massive expenditure of energy. That is the second law. You can't get something for nothing.
But you can create new constraints. Look at the CERN particle accelerator example. You take diffuse energy, you accelerate it, and you slam it together. You are changing the boundary conditions through compression and collision. And instantly, what happens? New mass forms. Structure emerges. Symmetries break. That diffuse energy wasn't dead. It was just waiting for a new constraint to be applied.
But you had to build the Large Hadron Collider to do it. That's my point. You're ignoring the massive energy debt incurred just to build the machine that creates the constraint.
I'm not ignoring it. I'm engaging with the definition of the universe. Enfield argues that heat death implies a multiverse of dead zones. If parts of the universe become truly useless and stop interacting, they effectively leave reality. And that violates the definition of a universe, one turning. If it's one system, everything has to participate.
That is a compelling metaphysical argument, I'll grant you. But let's talk about the static observer bias he mentions. He claims we call energy waste because we're static observers. But the reality is, we are static observers. We're biological entities that require specific temperatures, oxygen levels, and caloric inputs. If the universe reconfigures itself into a state that doesn't support carbon-based life, it doesn't comfort me to know that the energy is still there. I'm dead.
You are dead, yes, but the physics isn't. And that is the crucial distinction Enfield is making. We are projecting our biological fragility onto the cosmos and calling it a law of physics.
But physics is a tool for us. The concept of free energy, Gibbs free energy, exists to measure what is accessible to do work now. I'm sorry, but I just don't buy that heat death is a fallacy just because the energy is still present. If the energy is distributed equally everywhere, there's no contrast. Without contrast, there's no flow. Without flow, there's no life. That's what heat death means.
But that assumes no new constraints ever arise. Enfield calls heat death unresolved potential under static rules. He argues that gravity, phase transitions, and self-organization are constantly introducing new constraints. The universe is not a steam engine that just runs down. It's a self-organizing system.
Until the expansion of the universe outpaces gravity. That's the cosmological concern. But I will concede one strong point here. His argument that high-entropy states are not inert. They're still causally active. A hot gas cloud still exerts gravity. It still emits radiation. So strictly speaking, you're right. It hasn't left the universe.
Exactly. And if it hasn't left the universe and the underlying laws are time reversible, then we have to move to the second point, the reality of time reversal. Enfield makes a very flat claim here. Time travel is not false.
That is the headline grabber for sure.
And he brings the receipts. This isn't sci-fi. He points to, let's see, Exhibit A, the CUNY Advanced Science Research Center experiments. They demonstrated something called temporal reflection.
I've read that paper. It involves metamaterials.
It's more than just metamaterials. They fired a wave packet into a medium where they could abruptly change the properties of that medium in time, not space, but time. The wave split, and one part of it evolved backward. The tail of the signal became the head. The signal literally evolved in reverse order. This is a physical instantiation of backward temporal evolution.
Okay, but let's be precise though. It's a time-reverse copy of a signal within a specific material. It's a very, very impressive piece of wave manipulation.
It is not a trick. It is observable reality. And it's not just CUNY. Look at Exhibit C, MRI and spin echo. Every single time you get an MRI, the machine uses a pulse sequence to reverse the dephasing of protons. It rewinds the local quantum state to recover the signal. We are engineering local time reversal daily in hospitals to save lives. So Enfield's point is, if we can do it for a proton and we can do it for a wave pocket, the barrier is engineering, not physics. It's the difference between impossible and not yet.
Okay, I see the logic, but I have to push back on the scale. There is a massive fundamental difference between refocusing a spin echo in a magnetic field and sending a human being back to 1997.
Is there a difference in principle or just in complexity?
Complexity is a principle at that scale. It's the Humpty Dumpty problem. You can reverse a spin because it has very few degrees of freedom. But a human being? You're talking about septillions of interactions. The amount of information you would need to control to reverse a macroscopic object it's astronomical.
Hard is not impossible.
True, but there's also the causality argument. In all of these experiments, CUNY spin echo, the lab itself is still moving forward in time. The scientist watching the screen is getting older. The so-called time travel is contained within a forward-moving bubble. You aren't creating a causal loop. You aren't killing your grandfather. You're just rewinding a tape while the rest of the world plays on.
And Enfield addresses this head-on. He says we are conflating rewinding a tape with rewinding the universe. But if you can rewind the tape locally, you have proven that temporal order is a degree of freedom, not a prison. The arrow of time is manipulable.
Locally.
For now, but that brings us to the third point, the crisis of authority. Why are we told it's impossible? Why does every textbook say time flows one way when the math says time is a coordinate? This brings us to his document, PhD versus Zach.
This is where the critique gets personal.
It's blistering. Enfield argues that if a PhD is earned by repeating a contradiction, affirming that the second law implies loss while the first law implies conservation, then the credential certifies obedience to tradition, not comprehension of truth.
I mean, that's a pretty harsh indictment of the entire academic system.
But is he wrong? He writes, and I'm quoting here, "If this burns your degree, it is not because I attacked it, but because it never rested on understanding to begin with."
I just think it's reductionist. Look, I defend the necessity of shared frameworks. Enfield himself talks about borrowed stability. Civilization functions because we rely on foundations we didn't build ourselves. If every engineer had to philosophically resolve the ontology of entropy before building a refrigerator, we'd still be chilling meat in caves. Credentials are a shortcut for trust.
But what happens when that shortcut leads you off a cliff? Enfield brings up the Laodicea thought experiment, the lukewarm stance. He argues that experts who teach waste are insulating themselves. They refuse to stand on the implications of the first law. They're neither hot, true believers in the math, nor cold, deniers. They're lukewarm. They keep the door open but refuse to walk through.
The Laodicea argument is fascinating. I'll admit, it connects to his point about the Declaration of Independence.
Right, that rights are unalienable because they are endowed by a creator, a source that's beyond human revocation.
And his point is that civic trust requires a foundation that isn't just human consensus. If rights are just something we voted on, well, we can vote them away. But applying that to physics. Look, metaphors like waste are necessary for education. You start with energy is lost to friction because it helps a 12-year-old understand why the ball stops rolling.
But we aren't talking to 12-year-olds. We're talking to PhD candidates who are still using the wrong language. Enfield argues that innocence is lost once you see the contradiction. You can't claim to be a neutral expert if your expertise is based on a linguistic lie.
I agree that once the contradiction is seen, you have to take a stance. Distinguishing innocence from deferral is a key insight of his. But I worry that dismissing the institution entirely leaves us vulnerable to crackpots. Enfield is clearly brilliant, but for every Enfield, there are 1,000 people shouting nonsense on the internet. Credentials filter the noise.
But if the filter blocks the signal, then the filter is broken. Let's look at the ultimate signal, general relativity.
This is point 4, the open door.
The mathematical possibility.
We know that general relativity allows for closed time-like curves, CTCs. The math allows for time travel. This isn't debated.
Well, in specific, very extreme conditions, rotating black holes, infinite cylinders, things like that.
But it allows it. And the only thing stopping it is Stephen Hawking's chronology protection conjecture. Note the key word. Conjecture. Enfield argues the burden of proof has shifted. Skeptics have to find a law of physics that forbids time travel.
That's a fair point. In a courtroom, and Enfield does write this like a closing argument, the burden is on the prosecution. And the prosecution hasn't found the anti-time travel particle.
And this is the synthesis. Entropy is the arrow of time. If entropy is reversible, which the echo experiments prove it is, then the arrow of time is manipulable. And if the arrow is manipulable and general relativity allows for closed time-like curves, then the door is open.
I'll concede the door is open, but I question what's on the other side. Enfield talks about exotic matter requirements for wormholes as if they're just minor details. We need negative energy density to hold a wormhole open. That's not something you can just buy at Home Depot.
Again, that is an engineering problem.
Maybe. Or maybe it's a soft prohibition. Maybe nature doesn't need a hard law to stop you. Maybe it just makes the energy bill so high that it's effectively impossible for us.
But effectively impossible is not impossible. That's the entire linguistic shift. We've moved from forbidden by God to too expensive. And that is a massive paradigm shift.
It is. I'll grant you that. It absolutely changes the problem from one of metaphysics to one of resource management.
So let's move to the conclusion. Where does all this leave us?
It leaves us in a universe that is much stranger than we like to admit.
Enfield's summary that the universe isn't running down, it is reconfiguring. He asserts that impossible is a word we use to protect comfortable limitations. The experiments, CUNY, spin echo, they prove the math is right and the language of time reversal is impossible is wrong. He wants us to demand coherence. If the words don't match the equations, trust the equations.
And I think that's the most valuable takeaway, even for a skeptic like me. We have to stop confusing our map with the territory. The static observer bias is real. We are limited by our biology, by our position in time. But we shouldn't project those limitations onto the cosmos itself.
Precisely.
That said, I do acknowledge the shift from mechanics to mereology, how parts relate to the whole. We are parts, the whole may be reversible, but the parts might get crushed in the process. So I agree that not yet is the scientifically accurate stance, but never feels safer because it keeps us from trying things that might break reality.
Or save it. If we understand that energy is never lost, we stop treating resources as finite and start treating them as management problems. If we understand time is reversible, we stop treating mistakes as permanent and start treating them as data.
That's a hopeful view.
It's the open door thought experiment. The door to temporal engineering is open. It has been open since the very first spin echo experiment. We just mistook the threshold for a wall.
And as Enfield says, innocence is no longer an excuse once the contradiction is understood. We know the door is there. The question is whether we have the courage and the engineering capability to actually walk through it.
And that is the challenge he leaves us with. Not to believe in magic, but to stop believing in false limits. To demand that our language matches our logic.
It's a heavy burden, but an exciting one.
Thank you for listening to The Debate.
Until next time.